All right, folks, welcome to week 3 in DAX 601. This week we go over time data, strings, and joins. So our agenda, time data, strings, joins with a few subtopics in each, and then hotel bookings example is going to go over recoding, date, time data, and joins, which will be helpful for your challenge this week. So time data. Time data is traditionally really frustrating to work with, but Lubridate, the package that I asked for you to read this week, is really, really helpful in making things much more simple. So make sure you read through the Lubridate documentation, and then here I'm going to go over the main functionality. So first things first, Lubridate is going to convert string or numeric data into explicit date-time data. So you have 3 different types: date, time, which is time within a day, and then date time, which uniquely identifies an instant in the data by giving both the date and the time. When you use Lubridate, you'll see that your variable types come up as date, time, or DTTM, date, time. And you can also just use the simplest one for your data. So not every data set is going to have time. Sometimes they only have date, sometimes they only have time. No need to make things more complicated. You can just use whatever the simplest unit is in your data set. There's a few different ways to create date-time data. You can do so by reading in a file using readr. You can create date-time data from a string, from individual date-time components, so that's if there's a few different columns that contain date-time data, and from an existing date-time object. So first things first, reading in a file. What you need to know is this date format. The percentage, and then capital or lowercase y, m, b, etc. And so if you are reading in a data set that you know has a date time column, you can tell it, hey, the date is equivalent to this structure. So you say, okay, the date column that you're reading in is in structure of a number for the month, I think number for, 1 or 2 digits for the day, and then just 2 digits for the year. This table has all the different formats that you need for 4-digit or 2-digit year or abbreviated name and so forth, but you just say, hey, this is what you need to expect when you're reading in the data. You can also convert strings into date-time objects, and that's going to be using the various functions that represent year, month, day, year, date, day, month, year, etc., as well as HMS, so hours, minutes, and seconds. You can have any order of combo with these, so year, month, day, hour, minute, second, minute, hour, second, whatever. And you just say, okay, this is the order that the string is in, convert it into a date-time object using this function. You can also specify time zone with the TZ equals argument. And UTC doesn't use daylight savings, so that's going to be a good bet if you're going to be using time zone data. All of this, pretty simple. You have a string, you run one of these functions on it, and then the output is a date-time object. You can also have different columns. Often you'll have in a data set a month column, a year column, a day column, and you can make date or make date time by combining those individual columns as the arguments. So it goes from month, day to just a single column. And existing date time object, let's say that you want to convert date time to date, you just want something a little bit more simpler, as date, and the other direction as date time. You can also pull out individual date time components. So if you want to pull out the year in a date, you just use the function year, or month. Argument label, if you use label equals true in this call, it's going to return Jan, Feb, etc., as opposed to January, February, and so forth. Same thing with weekday. If you set the argument of label to true, it's going to return abbreviated weekdays, Monday and Tuesday. And so you can pull out all of these individual time components using these functions. So the functions, I think, are pretty self-explanatory. They say exactly what you want them to do. The main thing is going to be pulling in from strings, so making sure that you're careful about the input. If the date is ordered as month, day, year, making sure that you use the MDY function. And then here, you can again pull out exactly what you're looking for with MDay, month, etc. important thing. When it comes to time data, and I didn't ask you to read this chapter, I'm just pulling out this particular example. When you are dividing months or decades, this is really common with decades, you can use what's called modular arithmetic. In R, that's going to be percentage / percentage. And this is going to be division that leaves a whole number. So I have an example of this in the code, but this is going to be helpful if you want to break years down into decades. You can divide by 100, then multiply by 100 using this arithmetic. Another way to do that is cut. Again, I didn't ask you to read this chapter, but if you want to learn more, chapter 13.4.3 and 13.4.6 talks about this. Cut is a function that bins a numeric vector into discrete buckets. So if you want to cut into different decade formats, this is going to be a way to do it. Just a word of caution, if you want to use cut, there has to be one less label than break. So with cut, there's labels and breaks, has to be one less label. So let's go to our code example here. Great. So in this script, you're going to need the tidyverse and NYC flights data. We'll start with the time data here. So time data. This section is going to use functions from Lubridate that I've just been talking about in the lecture. Today is going to pop up today's date in the console. So today is 7/22, the first day of week 3. And then now also pulls up that I'm recording this video at 8:17 in the morning. So let's say we want to read in a file and specify that this file has a date column. I'm just going to first create a mock CSV. Great, okay, I was just making sure that Loom was sharing my screen. I've created a mock CSV that just has a single date column here. And what I can do is say, hey, let's read in the CSV and let's have the column format be month, day, Y. So here I've specified month, date, year, and let's look at how this variable is organized. It's organized as 2024 7/11. Great. Let's say that this date, that this represents day, month, year. If we look here, now it's 2024 11/07. So month, day, year, 2024 7/11, day, month, year, 2024 11/07. So be very careful about the order that you do this. Same thing here. If I say that the first value is year, the second value is month, and the last value is date, then this pops up as 2007 11/24. So you see, telling what order your string values are in is really important to use the right formatting, because each pops up with a different value here. From strings, we can also just read in a date value from strings here. This, let's say 2002-05-23, that starts with year, then month, then day. Great, that pops up fine. Month, day, year, you can see that these functions can take various formats. So I have the 4-digit year separated by dashes. Here is just a text, how you would typically write this. Here we have separated by the slashes, dashes. But regardless, it knows what order I put this in because I've specified it by what function I use. So here I say month, day, year. Okay, it knows that October is the month, that 25 is the day, and 2008 is the year. Day, month, year, it knows that 5 is the day, 12 is the month, and 1994 is the year. You can also use time zone. If you want to set a time zone, you can set that as UTC. And you can expand the function to include hours, minutes, and seconds. From individual components, So for this, I'm going to pull in the Fed funds rate data. We use this in some of our challenges, so it should be pretty familiar for you if you've already started looking at challenge 3. And here we can see immediately, okay, year, month, and day. What I can do is I can combine all of these columns into just one. So I'm creating a new data frame called Fed funds rate time, opening up Fed funds rate, then I'm mutating. Date is equal to make date, the make date function, year, month, day. So that tells it, okay, I want to pull together year, month, and day. And then I just want to relocate this column to the front so that I can easily see it when I use the head function. Great. So we went from year, month, and day being separate to now this is a good date object type. And we can pull out individual date time components. So let's say we don't have the original month, day, or year columns in the federal data. Let's just pretend. What we can do is we can pull from the data set. So I'm pulling from this one that has that date type object that we created. I'm creating month 1 as a column, and I'm going to say that it's month of date. So this month function is going to pull out the month component of our date column here. I want to use the label, I want to use the abbreviated label, and then just to give you some teasers of visualizations, I'm going to plot this. So here, what I've done is I've used ggplot and I'm pulling out that month 1 data. So here, I've just pulled out January, February, March, etc. You can also calculate using today and a date column. So let's say you're asked, how old is someone based on the data? I can say that my age, I can use today minus, and then I'm using year, month, day of my birthday. So that's my value, Larry age. When I first ran this command, when I first wrote this script, I was 9,491 days old. Now I'm 9,501 days old. So that's a really great way that you can use today minus a particular column to see a duration of time. Hint, this will be relevant for your challenge. But 9,000 some days means nothing. I have no idea how many years that is. So we can use as duration, and that will tell me that I'm approximately 26.01 years old. I was a little bit under 26 when I wrote this. Now I'm a little tiny bit over 26. We can also group data by decade. So this is what I was talking about with modular arithmetic. So let's say I'm interested in the inflation rate of the federal fund data, and I want this to be across decades because that's just a unit that makes the most sense. What I'm going to do is just create a new data frame so that way you have the example if you want to go through the difference between the various ones. I'm opening up my original federal funds rate data. I'm mutating, and I'm calling decade 1 as year divided by 10 using that modular arithmetic. So let's see what happens when we do this. If we just leave it as divided by 10, then it's just going to be 195, 195, etc. When really we want it to be 1950. So I'm creating a column called decade 2 that shows how to do it properly. This is just showing you why when you use the modular arithmetic, typically you're going to be divided by 10. You also then have to multiply back out. So what it does, if let's say the day is 1956 or 57, it reduces it to 1950, but you have to multiply so that it's 1950 as opposed to 195. So here, great. Let's look at Fed funds rate modular. Decade 2, we go from 195 to 1950. So let's go ahead and do this. Fed funds rate. I'm mutating with modular arithmetic, grouping by decade. I'm going to summarize the average inflation rate, and then I'm arranging in order of inflation. So here we see 1970 has average inflation of 6.48, 1980 6.08, and so forth. You can do the same thing using cut. So here, the way it works is I'm creating a new column called decade cut. I'm cutting a year, so I've identified the column that I want to cut by. My breaks are going to be 1949 to 2020 by 10. So this tells it that I want the decades 1950 through 2020, but I have to reduce by 1, so that way it breaks properly. I have my labels. Remember, there has to be one less than breaks, so my label ends at 2010. So going from 1950 to 2010 by 10. Right is true, meaning that the intervals are right closed. So whatever is on the right, that's like a hard stop. Include the lowest value is true, and then I want to format by year. Then I do the same thing, group by decade, summarize. So I create my column name, average inflation equals mean of inflation rate. Here I have to use the back quotes because inflation rate has a space in it, so R won't know what to do with that. And then a range. So using cut, we get the exact same value. 1970, 6.48, 1970, 6.48. So that's a brief intro on time. And next session, we'll talk about strings.